The next part of this section 2 looks at the responses taken thus far, including adaptation, mitigation actions, and the policies, and basically concludes that we are not on pace to meet the net zero goals, decarbonization, global warming targets 1.5, 2 degrees C, and so on. And then we'll come to see what has been done and what needs to happen, even including finances and so on. Responses undertaken to date: international climate agreements, rising international climate agreements, rising national ambitions for climate action, along with rising public awareness, are accelerating efforts to address climate change at multiple levels of governance, which is good news. Mitigation policies have contributed to a decrease in global energy and carbon intensity. So the GDP growth is not consuming as much energy as before, and energy demand is being met more and more with renewables and so on. With several countries achieving greenhouse gas emissions reductions for over a decade now because of these. Low emission technologies are becoming more affordable, with many low or zero emissions options now available for energy, buildings, transport, and industry. Lithium price has dropped, EV prices are dropping, but some people get left behind, so there are other socioeconomic details there as well. Adaptation planning and implementation progress has generated multiple benefits, with effective adaptation options having the potential to reduce climate risks and contribute to sustainable development. Later on, we have to also look at the adaptation and mitigation actions and their interactions with sustainable development goals. They are not always synergistic, so we have to make sure that they don't contradict each other. Global tracked finance for mitigation and adaptation has seen an upward trend since AR5, but falls short of the need. So we can say this with high confidence. So here is again coming quickly to renewable electricity generation, which is increasingly price competitive, and some sectors are now electrifying. So market costs since AR5, the unit costs of some forms of renewable energy and of batteries for passenger EVs have fallen. I have recorded this elsewhere also from reports from the IEA, for example. So below this point here, costs can be less than fossil fuels. So fossil fuel cost as of 2020 was here, and you can see that photovoltaics, onshore winds, and offshore wind have all fallen into the range where they are more affordable than fossil fuel. Of course, doesn't mean it's available and accessible to all. And then passenger electric vehicles, lithium-ion battery packs here, costs in dollars of 2020 per kilowatt hour have also dropped from over 1,500 by before 2010 to now a couple of $100. So that's a serious drop in price. Market adoption: since AR5, the installed capacity of renewable energies has increased multiple times. So if you go from 2000 to 2020 and look at adoption in gigawatts, these are on different scales here. So 2010 was somewhere in the range of 2010 is here. So we are talking here about market cost with range, fossil fuel cost, and adoption, noting the different scales. So those are the scales used here. I mean the color codes used here. So 2010 here, this is adoption costs of EVs. So these are again corresponding to the same thing: photovoltaics, onshore wind, and offshore wind, and EVs. So all of them have had multiple fold increase in adoption in gigawatts, and in EVs the adoption in millions of EVs is also increased quite a bit. Looks super exponential, but it can be misleading because the market share of the EVs is still not that high. It's somewhere around 5%. Globally, with higher numbers in some countries, which means the internal combustion engines are still around, and one has to watch out for additional investments in continuing building ICEs, which can be a lock-in for the future, which we don't want. Looking at current mitigation and adaptation actions and policies, they are not sufficient. So at the time of the present assessment, there are gaps between global ambitions and the sum of declared national ambitions. These are further compounded by gaps between declared national ambitions and current implementation of all aspects of climate action. For mitigation, global GHG emissions in 2030 implied by the nationally determined contributions announced by October 2021, some of them have been revised submissions, would make it likely that warming will exceed 1.5 degrees C during the 21st century and would make it harder to limit warming below 2 degrees C. We have seen this as emissions gap elsewhere, the voluntary and non-voluntary or conditional and unconditional NDCs, and how they are insufficient to meet the 2 degrees C target as well. Despite progress, adaptation gaps persist, with many initiatives prioritizing short-term risk reduction, hindering transformational adaptation. So this social scientists often used this transformational adaptation, which basically means the systemic changes have to occur very quickly as well, and not make incremental changes which lock in the current lifestyles for the longer future. Hard and soft limits to adaptation are being reached in some sectors and regions, while maladaptation is also increasing and disproportionately affecting vulnerable groups. Systemic barriers such as funding, knowledge, and practice gaps, including lack of climate literacy and data, hinders adaptation progress. Insufficient financing, especially for adaptation, constrains climate action in particular in developing countries, which is known again with high confidence. So basically we are not on track, even though awareness is high, intentions are there, agreements are there, policies are being designed, finances are increasing in to facilitate adaptation and so on. Emission and implementation gaps associated with projected global emissions in 2030 under nationally determined contributions and already implemented policies. So you are looking here at median projected global emissions, implementation gap between implemented policies and NDCs. So what is implemented and what is promised, emissions gap between NDCs and pathways to limit warming to 2 degrees C with 67% probability with immediate actions, and emissions gap for 1.5 degrees C with 50% probability. So implied by policies implemented by the end of 2020 in gigaton CO2 equivalent per year is at 57 with the range. Implied by nationally determined contributions announced prior to COP26, unconditional elements and conditional elements. So these are the numbers, you can look at them. Basically unconditional is which the countries will do anyways, whereas conditional will require financial assistance and maybe technology transfers, IP availabilities to make the implementations possible. Okay, so obviously we are struggling with these things, and these numbers are always lower than here, because if you include conditional elements, then you go further than just what you would do on your own. Projected global greenhouse gas emissions from NDCs announced prior to COP26 would make it likely that warming will exceed 1.5 degrees C, as we said, and also make it harder after 2030 to limit warming to below 2 degrees C. So we're looking here at greenhouse gas emissions in gigaton CO2 equivalent per year, historical period here coming into 2021, I think here, and then you see the ranges going into where we need to go for 1.5 degrees C, for 2 degrees C, and then limit warming. So overshoot allowed here. Trend from implemented policies looks quite bad in terms of where we would end up by 2050, very far away from where we need to be. So in many ways we are already behind. So if we are in 2023 already, and this 1.5 and 2 degrees C plans, the drawdowns should have, or reductions in emissions should have already started by 2020, but obviously we are not there, especially after COVID slowdown and reductions in emissions by something like 7% globally. We are back to where we were before COVID, so that's not good news. So in 2030, these are the various things we have looked at in terms of where we need to be to meet these targets. And these would be the so-called emissions gap. So to be on track to limit warming to 1.5 degrees C, we need much more reduction by 2030. 2030, so that's 4.3%. Past greenhouse gas emissions and uncertainty for 2015 and 2019 is shown here, so you can see that the uncertainties are large. You should keep this in mind, because when we come and talk about remaining carbon budget, the warming is linearly proportional to the accumulated carbon since 1850, so each additional ton has some warming. So if you want to calculate how much is left to reach 1.5 or 2 degrees C, you come up with a number, but you have to remember there are always uncertainties in those numbers. So taking current emissions rates and translating it into number of years remaining to save the planet are not good language, as many social scientists would and political scientists would tell you, because they can be misused for political purposes and other nefarious activities. Okay, so looking at understanding net zero CO2 and net zero greenhouse gas emissions, some details are given here. Limiting human-caused global warming to a specific level requires limiting cumulative CO2 emissions reaching a net zero or net negative CO2 emissions, along with strong reductions in other greenhouse gas emissions. Okay, so obviously there will be irreducible emissions, which means we will need net negative emissions, so we will need to draw down more than we emit to stay net zero or go net negative. Reaching net zero CO2 emissions is different from reaching net zero greenhouse gas emissions. So just CO2 can be misleading, because methane and N2O can delay everything in terms of the global warming targets, and when we hit effective net zero and not just net zero CO2. Achieving global net zero GHG emissions requires all remaining CO2 and metric weighted non-CO2 greenhouse gas emissions to be counterbalanced by durably stored CO2 removals, which we can say with high confidence. Basically, we are relying on these technological promises that scalable carbon capture will come along, and all the future trajectories rely on this, including bioenergy and carbon capture and sequestration. So we are really promising ourselves things that hopefully will work out, but we don't know what will be the worst outcome in terms of failure to accomplish those technological promises of the future. Global net zero CO2 or greenhouse gas emissions can be achieved even if some sectors and regions are net emitters, provided that others reach net negative emissions. So some people may reach net negative emissions, let's say in Scandinavian countries, which are small, rich, and are very progressive, and maybe some other countries will not reach net zero. The adoption and implementation of net zero emissions targets by countries and regions also depend on equity and capacity considerations, which we can say with high confidence. So who gets left behind, and whether the vulnerable countries will be carried along with this progress on net zero, decarbonization, systemic removal of carbon traps and so on, has yet to be seen. Continuing this is box 2, looking at scenarios, global warming levels and risks. Basically explains how things are done, since this is a synthesis report. Model scenarios and pathways are used to explore future emissions, climate change related impacts and risks, and possible mitigation and adaptation strategies, and are based on a range of assumptions. Okay, there is new papers out now saying that social scientists basically cannot predict societal changes, which really puts some damper on these things, which assume a lot of things for the future. You can also look at the Russian invasion of Ukraine or COVID to see how that has cascaded through the global human society, and wonder whether our future assumptions will be held true against all the geopolitical and other perturbations. So socioeconomic variables and mitigation options also include a lot of assumptions here. These are quantitative projections, are neither prediction. These are quantitative projections and are neither predictions nor forecasts. Technically, I can go back and edit these fumbles I make, but I'm not going to do that, so you have to just live with it. Global modeled emission pathways, including those based on cost-effective approaches, contain regionally differentiated assumptions and outcomes, and have to be assessed with the careful recognition of these assumptions. Most do not make explicit assumptions about global equity, environmental justice, or intra-regional income distribution. IPCC is neutral with regard to the assumptions underlying the scenarios in the literature assessed in this report, which do not cover all possible futures, obviously. I have separate podcasts on how the financial networks, central banks are trying to deal with things like ESG, environmental, social and governance issues, which is becoming a compliance requirement, also financial risks and how they are affected by climate risks and so on. So those have to somehow try to work together with the future scenarios as well, and that's what they do. They take climate projections and create scenarios for financial scenarios. Socioeconomic development scenarios and pathways. We have talked elsewhere about how SSPs work, so how they work, so I won't go into the details here. Risks is worth reading. Dynamic interactions between climate-related hazards, exposure, and vulnerability of the affected human society, species, or ecosystems result in risks arising from climate change. AR6 assesses key risks across sectors and regions, as well as providing an updated assessment of the reasons for concern, the maps we had seen, or the scales we had seen going into amber colors and so on. 5 globally aggregated categories of risk that evaluate risk accrual with increasing global surface temperature. They had unique threatened systems, ecosystems, and so on and so forth. Risks can also arise from climate change mitigation or adaptation responses when the response does not achieve its intended objective, so things like maladaptation, or when it results in adverse effect for other societal objectives. If you think of geoengineering and solar radiation management, for example, already huge efforts are going on to push this as a viable option to reduce energy coming in, to reduce warming, with lots of caveats and warnings, which I have in other podcasts. So those would have unintended consequences for sure, unless we design them incredibly carefully. So those also show up as risks for the future. Okay, scenarios and warming levels structure of our understanding across the cause-effect chain from emissions to climate change and risks. AR6 integrated assessment framework on future climate impacts and mitigation. So you have mitigation policies and adaptation policies and socioeconomic changes. These are basically transitions. So you have emissions coming from socioeconomic changes that change climate, which then drive impacts and risks, which determine your adaptation policies, and then you have feedback from socioeconomic changes also to adaptation demands, impacts, and risks, and they also influence societal changes. Of course, mitigation policies act on emissions, which in turn feed into climate and then impacts and risks. These are some things we have already looked at: CO2 emissions for shared socioeconomic pathways based on scenarios, and C1 to C8 categories, which I didn't go into the details. So here are the emissions in gigatons CO2 per year. Business as usual scenario, SSP 5, 8.5. So if you remember, we had RCPs for AR5 assessment report 5 used representative concentration pathways, which looked at the net additional forcing, like 8.5 watts per meter squared, 7 watts per meter squared, 4.5, and so on by 2100. SSPs combined shared socioeconomic pathways and emissions pathways to look at these scenarios as SSP 5, 8.5, which is basically business as usual. SSP 3, 7.0, SSP 2, 4.5 is kind of the middle of the road. And then you have what is needed for 2 degrees C and 1.5 degrees C targets in terms of SSP 1, 2.6, and SSP 1, 1.9. These include challenges to mitigation, adaptation, sustainability, regional conflicts, and so on and so forth. Temperature for SSP-based scenarios over the 21st century. You can see what will end up resulting from these emissions. Business as usual would give us warming of up to 5 degrees, and then you have here less than 2 degrees and less than 1.5 degrees happening here, with the range being shown here. So risks can be represented as burning embers. So reasons for concerns we looked at in terms of unique and threatened systems, for example. Main message is that some threats, some risks are already here, but with warming they all go up and increasing risk in this direction. So that's bad news, of course. So here are C1 to C8, which we will not read because they are various combinations of things on how they are done. For example, limit warming to 1.5 degrees C with greater than 50% probability, but there is no or limited overshoot, and then you have other scenarios where a high overshoot is allowed, or other limits of warming with various other probabilities are assumed, but these allow for different levels of emissions in these scenario evolutions here. So these are the greenhouse gas emission scenarios in SSP XY star in working group 1 and 2, so scientific basis, adaptation, mitigation, and so on. So here are the combinations of SSPs and RCPs. So determinants of risk then include climate impact drivers as hazards, vulnerability, which is a function of socioeconomics, per capita GDP, infrastructure, other things, exposure, again a function of population density, infrastructure, etc., and response. This has been added since AR5. Used to be just hazard, vulnerability, and exposure. Now they've also added response. Okay, so that's basically section 2, which is titled current status and trends, which also included trends in mitigation and adaptation, to basically argue that there are huge gaps in terms of meeting global warming targets, and we are going too slow on actions and responses in terms of mitigation, adaptation, and policies. NDCs that are even revised are not sufficient. By 2030 they will not get us on track to be on target for 2 degrees C or 1.5 degrees C. 1.5 is pretty much over by now according to most estimates, but just to be optimistic, you can always imagine that some scalable carbon dioxide removal, or ocean carbon dioxide removal, or some amazing geoengineering technique, or some jump in renewable efficiencies, etc., battery storage will come along, which will still make 1.5 degree possible. But in the meantime, we have to just watch out for infrastructure and other lock-ins that tie us to fossil fuels and industries with high emissions and so on. So we'll come back and look at section 3 in the next podcast. Okay.